Alright, so in this problem, I have x to the power of x is equal to x to the power of 2. So I want to find the value of x here. And for my solution, start by rewriting this as x to the power of x is equal to x to the power of 2. And now I'm going to divide both sides by x to the power of 2. So then these two cancel out, and I get x to the power of x over x to the power of 2 is equal to 1. Now, if I have something in the form a to the power of m over a to the power of n, and make sure to remember this property because this is a very important property of exponents. But if I have something in the form a to the power of m over a to the power of n, this is equal to a to the power of m minus n. So x to the power of x over x to the power of 2 is equal to x to the power of x minus 2, and this is equal to 1. Now, from here, what I can do is take the ln, or natural log, on both sides. So I get ln x to the power of x minus 2 is equal to ln of 1. And the reason I did this is because we have x as a normal term as well as an exponent. So we want to get this exponent down to be a regular term. And the way I can do that is by taking the ln on both sides. And if I have something in the form ln a to the power of b, I can move b to the front. So this is going to equal b times ln a. So over here, I have ln x to the power of x minus 2, and I can move x minus 2 to the front. So then x becomes a normal term, which makes it much easier for us to solve for the value of x. So if I move x minus 2 to the front, I get x minus 2 times ln x is equal to ln 1. Now, ln of 1 is equal to 0. So I get x minus 2 times ln x is equal to 0. And this gives me two equations. I have x minus 2 is equal to 0, and I have ln of x is equal to 0. So these are my two equations for this problem. Now, for x minus 2 equals 0, this is simple to solve. All I have to do is add 2 on both sides. So then these two cancel out, and I get x is equal to 2. So this is one solution of x. Now for ln x equals 0, well, ln, it's basically asking ln of what is equal to 0. And how we solve this is we can take e to the power of both sides. So I get e to the power of ln x is equal to e to the power of 0. E to the power of 0 is equal to 1, so I get e to the power of ln x is equal to 1, and e and ln cancel out. So I get x is equal to 1. So now we have our two solutions, but we have to check if they're right, because several times we can get a solution and it won't work out in our equation. So going back, our equation was x to the power of x is equal to x to the power of 2. And our solutions were x is equal to 2 and x is equal to 1. So let's first start with x is equal to 2. If I plug in x equals 2, I get 2 to the power of 2 is equal to 2 to the power of 2's. So I plugged in 2's over here and 2 over here. 2 to the power of 2 is 4, and again 2 to the power of 2 is 4, so this is right. Now I'm going to plug in x equals 1 for this. So I get 1 to the power of 1 is equal to 1 to the power of 2, and 1 to the power of any number is 1, so I get 1 is equal to 1. Alright, so in this equation, I have 3 to the power of x to the power of 3 over 9 to the power of x is equal to 81. So, to solve this, I'm going to first write 9 as 3 squared. So I get 3 to the power of x to the power of 3 over 3 squared to the power of x is equal to 81. And if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So 3 to the power of x to the power of 3 over 3 to the power of 2 times x, so 3 to the power of 2x, is equal to 81. I'm going to rewrite as 3 to the power of 4. So now notice how I have everything in the base of 3. So this is going to make it much easier to solve. Now, if I have something in the form a to the power of m over a to the power of n, this is equal to a to the power of m minus n. So 3 to the power of x to the power of 3 over 3 to the power of 2x is going to equal 3 to the power of x to the power of 3 minus 2x, which is equal to 3 to the power of 4. And now, if I have something in the form a to the power of m is equal to a to the power of n, this means that m is equal to n. So x to the power of 3 minus 2x is equal to 4. And now if I subtract 4 on both sides, I get x to the power of 3 minus 2x minus 4 is equal to 0. Now we have an equation here, and this isn't a regular quadratic equation because we have a power of 3 here, and we have a missing power of 2. We don't have a power of 2. So to actually solve an equation like this, what we have to do is we have to test out values, and then once we get a value that works out, we have to use that one value to find all the remaining values that are solutions to the equation. So let's first start out with 1. If x is equal to 1, then I get 1 to the power of 3 minus 2 times 1 minus 4, which does not equal 0. Now if x equals 2, I get 2 to the power of 3 minus 2 times 2 minus 4. 2 to the power of 3 is 8. 8 minus 2 times 2 is 4, and 4 minus 4 is 0. So this does equal 0. So 2 is a solution. To be more precise, x equals 2 is a solution, meaning x minus 2 is equal to 0. So now what we're going to do is we're going to divide x minus 2 with x to the power of 3 minus 2x minus 4. So I get x to the power of 3 minus 2x minus 4 over x minus 2. And to solve this, we're going to have to use synthetic division, and if you guys don't know what that is, I would recommend watching a YouTube video on it. So our coefficients of our numerator is 1, -2, and -4, and then we have a 2 over here. I'm going to bring down 1. 2 times 1 is 2. -2 plus 2 is 0. 2 times 0 sorry, I actually did something wrong. We should have a 0 in here because, remember, we have a power of 2. So because there's no power of 2 here, we just put a 0. Now, if we bring down 1, we get 2 times 1, which is 2. 0 plus 2 is 2. 2 times 2 is 4. -2 plus 4 is 2. And 2 times 2 is 4. -4 plus 4 is 0. So we have a remainder of 0, and we get x squared. Our coefficient is 1 plus 2x, coefficient is 2, plus 2 at the end. So I get x squared plus 2x plus 2 is equal to this. And this also means that x minus 2 times x squared plus 2x plus 2 is equal to 0. So for this equation, I get x minus 2 is equal to 0, and x squared plus 2x plus 2 is equal to 0. For x minus 2 equals 0, x is obviously equal to 2, and we already got this solution before, so this is no surprise. Now for x squared plus 2x plus 2 equals 0, to solve this, we have to use the quadratic formula, which is -b plus or minus the square root of b squared minus 4ac all over 2a. So I get x is equal to negative 2 plus or minus the square root of 2 squared, which is 4, minus 4 times a, which is 1, times c, which is 2, all over 2a, so 2 times 1. And now this is equal to negative 2 plus or minus the square root of 4 minus a, which is negative 4, over 2, which is equal to negative 2 plus or minus the square root of 4 times negative 1 over 2, which is equal to negative 2 plus or minus 2i, square root of negative 1 is the same thing as I, over 2, which is the same thing as negative 1 plus or minus I. So my three solutions to the equation are x equals 2, x is equal to negative 1 plus I, and x is equal to negative 1 minus I.